Vanakkam. Welcome to this course on classics in neuroscience. For the past few videos, we've been looking at physiology of neuronal conduction or the action potential, how the nerve impulse is getting conducted across the neuronal cell membrane. In this video, we'll look at the seminal contributions of Hodgkin and Huxley just before the Second World War and just after the Second World War, and the contributions of Kenneth Cole in this whole story of the contributions of Hodgkin and Huxley. So, Hodgkin and Huxley were performing these studies together on the giant squid axon, and in 1939, just before the war, they recorded the activity in the giant squid axon, and they found that initially the resting membrane potential was around minus 50 millivolts, and during stimulation it reached plus 50 millivolts, a full 100 millivolts. So, it increased by 100 millivolts to reach plus 50 millivolts approximately. Their findings in a brief communication to Nature, and then they could not pursue their research because all physiological research was suspended due to the war. So, World War II interrupted their research, and they both had to go and contribute to the war effort. So, they had to essentially stop this exciting line of work on nerve function and neuronal conduction mechanism. After the war, they were generously supported by Rockefeller Foundation, and they could resume their work now with war surplus equipments that were now no longer needed for war effort. So, they could use these equipment for their research. There was renewed interest in studying ion movements across the neuronal membrane. So, the picture that was presented earlier also, how the recordings were happening, and so these ion movements are crucial to improve our understanding of the action potential. And Hodgkin and Huxley proposed that action potential essentially results from selective flow of sodium and potassium across the neuronal membrane. This was supported by rigorous experimental evidence, essentially changing our understanding of neuronal communication, because earlier it was just thought that there is this local circuit current that is happening, but now it is the physiological mechanism. How is this happening? Because of the entry of sodium ions inside the cell causes the rising part of the action potential, and the exit of potassium ions from inside the cell to the outside causes the falling part of the action potential, was first described by Hodgkin and Huxley, suggesting that it is the ion flow, that is a selective change in the conductivity or the conductance or the permeability of these ion channels upon stimulation. That is, during stimulation there is a change in the permeability and the conductance of these channels, leading to an exchange of these ions, causing this jump in electrical activity. So, this also explains the differences in ion concentration across the membrane, and how there is this rapid buildup of this potential, rapid change in electrical potential. This model has had a deep, extraordinarily profound impact on neuroscience, essentially the foundation for our understanding of how neurons communicate. Meanwhile, Kenneth Cole was renowned for his excellent pioneering work in the same field, in the electrical properties of neurons and their membranes, and he essentially introduced what is now a well-known experimental technique, the voltage clamp technique, that essentially revolutionized, completely changed the way in which we study ion channels in neuronal membranes. He collaborated with Hodgkin and Huxley. Actually, this collaboration started just before the war, continued, providing important, absolutely crucial insights, technological advancements that led to the groundbreaking research on action potential. So, this voltage clamp method, so you are having a stimulating electrode and you are having a recording electrode, and you are amplifying the output, and there is a reference electrode. So, this method was the Kenneth Cole's invention. This was used by Hodgkin and Huxley to study neuronal action potential. So, Kenneth Cole's work essentially laid the basis for improvement of this work performed by Hodgkin and Huxley here, that is essentially neuronal information or impulse transmission, the role of ion channels, and how ion channels changes the excitability of the neuronal cell membrane. With this, we come to the end of this video. In this video, we looked at the crucial research that was performed by Hodgkin and Huxley before and after the Second World War, and the critical seminal contributions of Kenneth Cole. This is essentially the voltage clamp method. What is the critical contribution of Hodgkin and Huxley? Ion flow hypothesis, that information flows because of changes in the permeability or conductances of the selective ion membranes or ion channels, selective ion channels.